Hi all, myself M.A. Stephen Raj, Assistant Professor in EEE Department, KSR College of Engineering. Today, we are going to discuss about the topic of hydroelectric power plant. This is the fourth stage of hydroelectric power plant. Here, the first stage is potential energy, that water is stored in the reservoir. The second stage is kinetic energy, that water is going to be falling in the penstock. The third stage is mechanical energy, that is spinning turbine. The fourth stage is that is electrical output, that is we can call it as generator output. Here the managing potential and the reservoir and gates. First we have water head and then control gate mechanism. In that water gate, the difference in height between the reservoir water level and the outflow. The greater the head, the greater the stored potential energy. Now next one is the control gate. The mechanical throttle indicates the exact volume of water released. Finally, the opening of the gate releases the maximum potential energy. This is the process of water head and control gate. The next process is called as penstock and the kinetic forces. Penstock is nothing but the pipe that water came from that upper storage to the lower storage. Next, the power generation, the transmission system. Here we have mechanical coupling system, electrical generator, and then transformer, that we can call it as power transformer or step-up transformer. Next, the master autonomy of hydro power plant. We have reservoir, control gate, penstock, generator, and the water turbine. This is the master autonomy of hydroelectric power plant. Now we are going to discuss about the hydro power plant layout. First we have reservoir. In that reservoir, normally the water is stored, we can call it as dam. From the dam, the surge tank is connected. Then from the surge tank, the valve hose, penstock, power station, and finally the tail race is connected in this hydroelectric power plant. What is the working of surge tank? In case any problem in the power station or in the valve hose, means we need to close the water that coming from the reservoir to the penstock. In that way, the surge tank that collect the excess amount of water from the penstock or from the dam. Then the pressure tunnel. The valve hose, here the valve, there will be a valve that will be going to useful for opening and closing the water from dam to the power station. Here then penstock is a huge amount of steel pipe which carries water from the reservoir to the turbine. The potential energy of the water is converted into the kinetic energy as it flows down through the penstock due to this gravity. This is the process of penstock. Next one is hydro power topologies. We have up to now we have seen that conventional type. Then we have another two types, that is pumped storage and runoff river. Pumped storage, here also the water is act as a reservoir, but we can drive in it as the peak load. The next one is runoff river. No dam or reservoir is needed. That oversupply passed usually in that runoff river. Now we can going to discuss about the pumped storage power plant. Here the pumped storage power plant, we have upper reservoir. From the penstock, the water accumulated in the upper reservoir that will be flows through the lower reservoir. The same from the lower reservoir that can be accumulated and collected to the upper reservoir. This is called as pumped storage power plant. This pumped storage power plant normally used as the peak demand. Water flows from upper to the lower reservoir. The second phase is low demand, that excess grid electricity pumps water from the lower reservoir back to the upper reservoir. This is the process of pumped storage power plant. Next one is natural flow, that is runoff river plant. This runoff river plant, no dam is constructed, no reservoir is stored. A portion of the river is simply diverted through a canal or penstock directly to the turbine. From the turbine, the alternator is connected, the electricity is produced by using the runoff river power plant. Thank you.